Hello everybody, welcome back to another episode of Leetle. Today we're going to be doing Leetle for the 28th of January 2025. We're going to be doing Leetle 28 today. Reverse integer. Write a function solve the reverse of the digits of an integer. If the reverse digit overflows, return 0. For example, 1, 2, 3 becomes 3, 2, 1. Should the output is a 32-bit signed integer. So the reverse integer must be within the range that. Interesting. That's a tricky one, isn't it? To reverse an integer. Is there some way that I could, like... It's not impossible, but it's a little bit weird. Import math for I in range. We're going to do... We want the number of digits that would be in this. So 3. So we want the ceiling of... No, it's actually... of n. Yeah. So for I in range, math ceil, math log n. We're going to do digits equals this. Whoops. Digits dot append. We're going to do math dot floor of n divided by 10 to the power of I. And then we're going to modulo that by 10 to the power of I plus, or no, the modulus 10. Should be mod 10. Okay, and then for j in range. Alright, so then we're going to have output equals 0. For j in range, len digits. We're going to do output plus equals digits minus j times 10 to the power of j. And then if output is less than 0, then return 0, else return output. That should be correct. Math domain error. Uh-oh. Is it just ceil? Does Python have ceiling and floor baked in? No, it's math.floor, math.ceil, right? It is math.floor, math.ceil. And then, okay, well, math domain error. Oh, it should be n plus 1, technically. That's very, very minor here. Okay. Math.floor of n divided by... Okay, let me just check. Python power. Do I have to do pow function? Okay, maybe I have to do that. Pow 10i. Pow 10j. Math domain error. That means that I'm inputting an invalid number into the logarithm function. Why? Does math.log have an upper bound? Oh. Shit. Nope, okay. Math.log of that divided by math.log of 10. Natural logarithm. Right. That's still wrong? Oh, shit. That's gonna be incredibly wrong here. This is just okay. Let's just do return output and ignore. Oh, this is annoying. Okay. Math domain error. Where? Math.log of n plus 1. Oh, it might be integer overflowing immediately? Is it just integer overflowing here? Is there math log have an upper bound? Value error, math domain error. That's what I'm doing wrong. Math.log of math.abs of n plus 1. Let's check. Python abs. Is it just abs? Yeah, okay, it's just abs. I don't even need math dot. Okay. And then, if output is greater than huh. 2 to the power 31 or is greater than equal to 2 to the power 31, then return 0. Else, return output multiplied by n divided by abs of n. This will just give us the sign. It's even more wrong. Division by 0. Oh. If n equals 0, return 0. Okay, here we go. 1, 2, 3. It failed. It should be 3, 2, 1. But I returned 0. Okay. math.floor of n divided by 10 to the power of I, which at the very beginning is 0, because I is, yeah, to the power of 0, which makes 1. And divided by 1, mod 10, means it's the last digit. So what's failing here? I don't know what's failing, and I don't know why it's not working. There's something here that's screwy. So okay, let's start with n plus 1. 1, 2, 4. Absolute that is 1, 2, 4. The logarithm of that divided by the logarithm of 10 means we're going to be somewhere in the world of like 2 point something. And then we're going to ceiling that to give 3. So for I in range of 3, we're going to have 0, 1, and 2. Digits.append math.floor of 1, 2, 3 divided by power of 0, 10 to the power of 0, which is 1. 1, 2, 3 divided by 1 gives you 1, 2, 3. Mod 10 is 3. Digits.append 3. First of all, this is wrong. The first place I should be doing this. That's more correct. So ordering also matters. I realized that I've made a mistake because it should be taking the first digit, then the second, then the third. Oh, no, it's not. No, this is correct. I could like conjunct it together, but I'm taking it from, yeah. So behind is correct actually. Whoops. Or wait, no, because it should be minus j. It's gonna be minus 0 at first. That's where it's gonna break. It's gonna be minus j minus 1. Okay, I'm gonna replace that entirely just to make sure I'm doing it correctly with len of digits minus j minus 1. That should just work then. Then which is 1. Power of 10 to the power of 1 is 10. 1, 2, 3 divided by 10 is 12.3. Floor of that is 12, mod 10 is 2, as expected. Then you repeat that a third time. So you're going to get 1, then 2. So you're going to get 3, then 2, then 1. And now, you're starting by getting the digits, the last one, which is length of digits, which in this case is 3, minus 0 minus 1 is 2, times 10 to the power of 0, which is times 1. Up plus equals that. Oh. How 231. Because I don't know if that notation actually works. Ah! Damn it. Okay. The only test case that I failed on was test case 2. What did I return? 778? Why? Oh! Balls! Oh! That should be an absolute. Fuck! Yeah, there we go. Yeah, I had some issues there a little bit where I couldn't figure it out, but yeah, so I got it in 7. That definitely solves. I'm gonna actually quickly put it into. I'm gonna put it into a browser to see if that actually works as intended. Yeah, fucking course it does. God damn it. That's still a failure, but it not being able to see what the errors are or be able to do tracing and only getting 6 attempts is genuinely brutal. And this is an example of one where but if I had seen this, I would have immediately known what the problem was. But I had a bunch of cases where it's just, why is the logarithm failing? and I didn't understand why. Not to mention that the weird power stuff. The fact that some of these things I have to do math on and some things I don't. Why doesn't Python just innately have a bunch of like math related things? Like that should just exist. Um, but yeah, I got there in the end. Ish. Not really, but eh. Thank you all for watching. Hope you guys enjoyed, and I'll see you all next time. Cheers.